Program is rated GE. Content carried in here is suitable for general family viewing.
Good afternoon, everybody. Welcome to this session of KUTV. I am Mr. Brian Odongo, a teacher from St. Teresa de Lima Girls Secondary School at Machakos County. Welcome to this session of Mathematics Form 2. Today, I am so much privileged to share with you a topic called gradients and equation of a straight line in Form 2. So that is the topic of the day. Okay. So today, as I've said, we are dealing with Form 2 mathematics. The topic of the day is gradients and equation of a straight line. So this is our topic of the day. This is our topic of the day. It's called gradients. The topic of the day is called gradients and equations of straight line. Gradients and equations of straight line. Equations of straight line. So this is the topic of the day. Gradients and equations of straight line. Those are the topics of the day. Now, in this topic, gradients and equation of the straight line, our main focus today will be under the subtopic gradient. That will be our subtopic of the day. So let's check on gradients. Now, this gradient, I want to have a better understanding of the subtopic gradient, students. Are we together? Please, I need you all to be very much attentive in this subtopic because it lays a basis for a better understanding of this topic. Now, maybe before I literally tell you what a gradient of a line is, I like to give you a real life case scenario of workers. Maybe we call them builders. These builders that sometimes they have to lift their loads to some certain heights. For example, say someone who is a constructor is requesting for cement at a certain height, maybe say 3 meters above the ground. How will this cement from the ground be lifted to this person up there with ease? So this is the case scenario. Maybe we have a level ground here. This is our ground. But now, this is a construction site, remember. It is a construction site. And in this construction site, the construction is being done here at a height 3 meters above the ground. That is the point where the construction is occurring. Now, for someone maybe to transport some materials from the ground here to this height of 3 meters, maybe there are some 2 ladders being used. I call ladder 1 and ladder 2. Maybe I call this one here a ladder 1 and ladder 2. Now, those 2 ladders are positioned such that ladder 1 here, it is 2 meters away from this point. Maybe the distance from here to here is 2 meters, students, is 2 meters. So look, the base positioning, this ladder 1 is positioned 2 meters away from the base of the wall, Then you have also ladder 2. Which is maybe positioned 2.5 meters away from the wall. 2.5 meters. Maybe now the distance from here, where ladder 2 is, to the wall here, this distance here is 2.5 meters. That distance there is 2.5 meters. Now, for us to transport these construction materials from the ground here to the construction point there above, that is 3 meters higher above the ground, we have to look at what between ladder 1 and ladder 2, which ladder can we use easily without using a lot of effort? Can we use ladder 1 or ladder 2? So we have to make that decision. Now, in order to know which ladder we are going to use, we are going to compare the vertical distance and the horizontal distance. Are we together, students? So the comparison, the ratio now between the vertical distance and the horizontal distance will literally tell us which ladder are we going to use. Are we going to use ladder 1 or we are going to use ladder 2? So for example, let's check the case scenario for ladder 1. If you want to get that of ladder 1, you will realize that in order to get used to ladder 1, it is if the vertical distance is 3 meters and the horizontal distance is 2 meters, therefore the height of this ladder 1, it will be this slant height. So this will be, it is the vertical distance. It is the vertical distance. You divide it by the horizontal distance. You divide it by the horizontal. You divide it by the horizontal distance. Now, when I'm talking about the vertical distance, it is simply the distance from the ground vertically to where the construction is happening. The distance, that distance. And when I'm talking about the horizontal distance, this is the distance I'm talking about. So for that you'll realize that, the vertical distance is now 3. We are dividing it by our horizontal distance. We are dividing it by our horizontal distance, which is 2. Now, when you divide 3 divided by 2, students, what are you getting? Yes, we are getting 1.5 students. So that is that. Now, what about, this is for ladder 1. What about if we consider ladder 2? What about if we consider ladder 2? Now, when you are trying to consider ladder 2, still the case scenario for ladder 2 is the same. I've said it is the vertical distance over the horizontal distance. The vertical distance over the horizontal distance, students, isn't it? Yes. So, the vertical distance, let's look. This ladder 2, still the vertical distance is the same, students, isn't it? because I can see the distance here is still 3. So for ladder 2, it is the vertical distance is 3, but now the change happens in the horizontal distance. The change happens in the horizontal distance. Now, the horizontal distance of ladder 2 from the bottom of the hole, you realize that it is 2.5 meters, students, isn't it? Yes, 2.5. 2.5. Now, remember that whenever you are sitting for any question of mathematics, a calculator is very, very important to you as a student. This is simply to enhance your level of accuracy. Your level of accuracy. So, we get back into your calculator wherever it is. So, get into your calculator. Then, it is 3. You key in 3 divided by 2.5. When you take 3 divided by 2.5, you are getting what? 1.2. Yes, so here you'll get it is 1.2. This is for ladder 2. This was for ladder 1. Now we do the comparison. Now we do the comparison between ladder 1 and ladder 2. Therefore, you realize that a transporter will most likely use ladder 2 compared to ladder 1. Why would a transporter use ladder 2 in comparison to ladder 1? It is simply that because with the ladder 2, you are most likely to use less energy. With the ladder 2, you are most likely to use less energy. Now, this comparison, this ratio concept of the vertical distance against the horizontal distance gives us what we call the slope, isn't it? It gives us this a certain measure of the slope. Now, remember that the topic is gradient. Therefore, what is this gradient? Gradient is simply defined as the measure of the steepness or the slope of a line. Is simply what we call a gradient. So, basically, we say that a gradient, what is a gradient? Is the measure. Gradient is the measure. Gradient is simply the measure of the steepness. Is the measure of the steepness. When you talk about this steepness, in some books, you will find it being talked as the slope. So can be called steepness or in bracket, slope of a line. Slope of a line. So gradient is simply the measure of the steepness or the slope of a line. Now, what do you learn from this? The steeper the line, the higher the gradient. I don't know if you've noted that. Let's compare our ladder 1 and ladder 2. You realize that ladder 1 is more steeper than ladder 2. Being that it is more steeper than ladder 2, it has got also a higher gradient compared to ladder 2. Therefore, we say that the steeper the line, the higher the gradient, students. Are we together up to that point? Thank you. Hope you've all understood first this concept, what a gradient is, isn't it? Yes, because this same concept we've applied here in analyzing this concept about the builders is the same concept we are going to apply when you are calculating the gradients of straight lines. When you are calculating the gradients of straight lines. Now, before we dive into an example, let's have this analogy that gradients of straight lines are determined in the same way as we've determined these measurements, that is the 1.5 and the 1.2. the 1.5, and the 1.2. Now, how do you calculate gradient in an exam? Maybe you are given some 2 points of a line, then you are told to calculate its gradient. Simply what you need to know is this. That in order to get the gradient of any line, any straight line, it is simply the change in the y coordinates divided by the change in the x coordinates. Hope students, you remember in Form 1, you are introduced to the concepts about the coordinate. And you are told we normally have the x coordinate and the y coordinate. Do you remember it, students? Wonderful, if you remember that. So today, we are going to apply the same. So this is the formula that you are simply going to use whenever you get a question on calculating the gradient of a straight line. You say that gradient, which I abbreviate as grad, is simply the change in the x coordinate all over the change in the y coordinate. Are we together, students? Yes, so we put that in point form, that gradient is simply change in the y coordinate all over the change in the x coordinate over change in x coordinate. Now, hope again I want to take you back to your Form 1. You are drawing under graphs, you drew a Cartesian plane, isn't it? Hope you know the vertical axis is what we call the y-axis, and the horizontal axis is what you call the x-axis. Here, I want you guys to be very keen. Here we are talking about this vertical distance, okay? This vertical distance is the one that is being referred to here as the y coordinates, and the horizontal distance are the ones going to be represented by the x coordinate, students. Now, this change in the y coordinates and the change in the x coordinates, you will find we are talking of delta y, delta x, okay? There is what we call delta in math. Now, this delta is simply used to represent small changes. So, delta is used to represent small changes. Always remember that delta is used to represent small changes. So when you go to some other books, they don't write these long statements like that. What they normally do, you will find they have written it for you like this: G is equals to change in y over change in x. So this D, this is what we call the delta. This is the symbol for the delta. It's more like that small triangle. So the dy over dx is what is called the gradient. That gives you what is called what? The gradient. Remember that we've said that the gradient is simply the measure of the steepness or the slope of a given line. Now, let's look at a certain example for a clear and better understanding, students. Let's look at example 1. Example 1. How do we work out that example 1? Maybe you find the gradient of the line PB below. So you can get a question. Find the gradient. Find the gradient. Find the gradient of the line BP below. You are supposed to get the gradient of the line BP below. now you'll realize that this gradient, this line BP would have drawn for you in this case, would have been drawn for you in this case. So this is simply what we call a Cartesian plane. This is our Cartesian plane. A Cartesian plane is normally made up of two axes. We have the x-axis and the y-axis. This one, the vertical line is the one we call the y-axis, while the horizontal one, this one here, is the one we call the x-axis. Maybe in this case you will find that this line which we call BP, the line BP, maybe it is this one here. Maybe that is your line BP. That is your line BP. Remember now that when you are plotting it on a Cartesian plane, this Cartesian plane, you have to choose a very uniform, suitable scale that is easy to interpret and read. That is easy to interpret and read. So maybe I say my scale is going in the range of maybe 2, 4, 6, 8, 10, like that. Then on the negative, this is obviously 0. This one is -1. Sorry, -2, -4, -6, -8, and so on. Then the y-axis, this is 2, 4, 6, 8. Then -2, -4, -6. Now remember that our main point of interest is to get the gradient of a line, okay? Now what is the procedure, okay? Whenever you are given a line, students, and you are told to get its gradient, this is the procedure that you're going to follow. The first step is identify any 2 points on that line. Are we together, students? Just any 2 points. Don't worry. As long as the points you've identified are on the line, then you are at the right track. Just any 2 points. This is what I mean. Let's come back to our diagram here, students. I want to identify any 2 points. For example, allow I identify this point here and this point here. Are we there, students? Now, after we've identified our points, let's write their coordinates. Remember that our coordinate is normally written in the form of x followed by y. Are we together, students? Follow x followed by y. So you have x followed by y. So when you look at the x, maybe for my case here, my x value is 4. Then my y value is 8. So the coordinate at this point is 4, 8. The coordinate at this point here is 4, 8. At one of the points I've picked. Maybe again I pick another point here. Maybe for this point, let's call, if you look at the x coordinate and the y coordinate is 4, 2 here. 4, 2. So you come and now, after you've gotten your points, you come and now evaluate on how to get your gradient. You simply say that gradient is change in y over change in x. When I'm talking about change in y, is the change in the y coordinates over the change in the x coordinate. So now let's look. When you come, my y coordinate here is 8, my y here is 8, my y here is 2. So the change is the difference between the two. So for the y coordinates, it is simply, that is 8 minus 2, 8 minus 2 over the x coordinate, which is, allow maybe if this one here is 3. So that will be 4 minus 3. 4 minus 3. 4 minus 3. So this is 8 minus 6 in your calculator. Sorry, 8 minus 2 in your calculator gives you a 6 over 4 minus 3 gives you what? 1. Yes, students. So 6 divided by 1 is giving you 6. So you realize that the gradient of that line is 6. That's how you get the gradient of any point, any line. First of all, identify any 2 points on the line. After you've identified any 2 points on the line and written down their coordinates, you now come and say gradient is the change in the y values over the change in the x values. That is how you get it. Now, we have these case scenarios. Maybe if this is your Cartesian plane, okay, you may have this line. I want you to be very keen, students, because there is something I want to emphasize on here. You have this line here. Allow I call it L1. L1. Then I have also another line L2. Look, my line L2, students, maybe it is running like this. I want you to be very keen with how those lines seem to be running. My line L2. This one maybe is my line L2. I may also have another line that is parallel to the, and I may also have another line that is parallel to the y-axis. Maybe this is the line. This line here is parallel to the y-axis. Allow I call it L3. Then finally, I may have a line that is parallel to the x-axis. So the line parallel to the x-axis, simply, it is this line here. Allow I call it L4. Now, when you do the computations of the gradients, dear students, you will realize that for L1, for this line that is running like this, it will be giving you what is called a positive gradient. Whenever you get its gradient, it will always be positive. But when you look at this L2, now, why are we saying that this gradient here is positive? When a change in the y coordinate results to a change in the x coordinate, that one is called a positive gradient. Are we together, dear students? Okay, but now with this L2, you see how it is running. You will realize that when you increase its x coordinate, it will result to a corresponding decrease in the y coordinate, meaning they are inversely proportional. So this one here we've said gives you a positive gradient. This one here, this L2, will be giving you a negative gradient. Dear students, we have also this line called L3. This line L3, we see that it is parallel to the y-axis. This line is parallel to the y-axis. Now, for the line that is parallel to the y-axis, it means that an increase in the y-coordinate does not affect the x value. An increase in the y-coordinate does not affect the x value. So that means the x value remains 0, isn't it? Now there is something I want you, dear students, to confirm it for me. When you take 0 divided by any number, what are you getting, dear students? 0 divided by 1,000, 0 divided by 2, what are you getting? Let's just confirm it for uniformity. You take your calculator, dear students. When you key in 0 divided maybe by any number, I can take maybe 89. I'm getting my answer as a 0. What does it mean? For this line that is, for this vertical line that is parallel to the y-axis, its gradient is always equals to 0. That's what I want you guys to note. That for this L3 here, the gradient will be equals to 0. Why is it equals to 0? For any change in y, there is no change in x. So x remains 0. So any number, when you divide it with a 0, the answer will always be a 0. Let's now look at this case, this line 4, which is the horizontal line parallel to the x-axis. That means that for any change in the x coordinate, there is no change in the y coordinate. That means that the y value remains as 0. So so for this one here, you realize that. Remember that it is change in y over change in x, okay? So for that one, the gradient is not defined. The gradient is not defined. It's called undefined gradient. Undefined gradient. Let's check on some examples here over what we've learned so far. I have a question that says, find the gradient of the line passing through point 2, 1, and 5, 10. Find the gradient of the line. Find the gradient of the line passing through points 2, 1, and 5, 10. How do you find that gradient of that line, dear students? It's just very, very easy. Remember that, students, mathematics is always the easiest subject, only if you keep doing at least 5 sums a day. That will really boost you. So we have the points 2, 1, and 5, 10. So the first point on that line is 2, 1. The next point is 5, 10. And you are supposed to get the gradient of that line. How do you go about that? You simply say gradient is equals to change in y over change in x value. Remember that this is x, this is y, this is x, this is y, dear students. So the change in y can be simply 10 minus 1 divided by the x value, the change that will be 5 minus 2. So you realize that 10 minus 1 is 9 divided by 2. 5 minus 2, you are getting 3. And when you take 9 divided by 3, what are you getting, dear students? Yes, thank you. You are getting 3. Therefore, it means that 3 is the gradient of the line passing through those points. You just find the change in y values over the change in the x values. That simply gives you the gradient of that line. That simply gives you the gradient of that line. Now, in some cases, you realize that you can be given a question like this. The line AB passes through points. So let's check on that. The line AB passes through points. The line AB passes through points A to -1, A to -1, and B 6, K, and another point B 6, K. If the gradient of AB is 5, if the gradient of AB is equals to 5, find the value of K. Find the value of K. Now you realize that now these are the most common questions that nowadays are being asked by examiners. This is mostly a 3-mark question in section 1. Now, it's not very challenging. What it requires you, are you able still to recall the formula for calculating gradient? Remember that under solution for that, you simply say this. I want to work it out as our second last example of the topic, of the subtopic of the day. Gradient, remember that we've said gradient is equals to change in y over change in x. Now, when you look at your point, the change in y is k minus -1. I want you to be very keen. K minus -1 over change in x. The x values here are 6 and 2. So 6 minus 2. So this ratio gives you the gradient, which is equals to 5, which I can say can be equals to 5 over 1. Can be equals to 5 over 1. So you know that negative times a negative becomes a positive. So this evaluates to k plus 1 over 6 minus 2 is simply 4. Should be equals to 5 over 1. Should be equals to 5 over 1. Then you simply cross multiply. That becomes k plus 1 equals to 5 times 4. 5 times 4. This becomes k plus 1 equals to 20. K plus 1 equals to 20. On collection of like terms, positive 1 on crossing the equal sign becomes what? Negative 1, dear student. So this is k equals to 20 minus 1. Therefore, k becomes equals to 19. So that is the value of k. You can get such a question. Then please make sure you joyride it because it's very, very simple. It's very, very simple. Let's check on the last example, which I have for you here. The line AB, we have a line. That line is called AB. Is passing through points. We have a point P, -3, -4. Then we have another, P -3, 4. -3, 4. Then you have another point, Q, which is K12. Q is K12. Then you are told the gradient of the line is 4. The gradient of the line is 4. So the gradient here is 4. Then the question is very simple. Find the value of K, which is our unknown. It is just the same case scenario as the other one that we did previously. So you come and say gradient is the change in y, which is 12 minus 4. 12 minus 4 over the change in x values, which is now k minus 3. Remember that it is k minus -3. I want you students to be very keen on this because this is the point where many students go wrong. They just tend to ignore. So 12 minus 4 gives you what, dear students? Yes, thank you. You get 12 minus 4 is 8 over k minus 3 becomes k plus 3. So now this one is the expression for your gradient, which will be equal to the gradient you were given in the equation, which is 4. So this expression here should be equals to 4. On cross multiplication, you realize that 4 into k plus 3 being equals to 8. When you open up the brackets, dear students, you get this will be 4k plus 4 times 3 becomes 12, should be equals to 8. Then when you are there, what do you do, dear students? Yes, thank you, Olo. What happens here is you collect the like terms, so it will be 4k equals to 8. When positive 12 crosses the equal sign, it becomes -12. So that will become -12. So this 4k equals to -4. So that means that k equals to -1. That is the value for k, dear students. So what have we learned today? Remember that we began by talking about the gradient. Basically, how you get a gradient is very important. We said for you to get the gradient of any straight line, it is the change in y over the change in x. That gives you the gradient of any line. We went further ahead and said a gradient can either be positive, negative, 0, or undefined. For a positive gradient, I showed you an example. When a change in x results to a corresponding change in the y value, therefore that one gives you what is called a positive gradient. When a change in x results to when an increase in x probably results to a decrease in the y value, that means that they are vertically opposite. That means that gradient will be a negative, okay? That gradient will be a negative. Then we said that the gradient is undefined. A gradient is undefined when the x value is 0. So that means that for horizontal line, that gradient is undefined. Then the gradient is always 0 for a vertical line, because 0 divided by any number is a 0. Okay, so before I finish up my topic, my subtopic of the day, allow I give you at least 2 takeaway questions so that you go and attempt to see how better you've understood the subtopic. Or maybe before I give out those questions, anyone with a question kindly? Okay, thank you, Maria. She is now raising up a question that what if, for the case you are given a certain equation, for example, yes, just give me your equation. Thank you. She's giving me an equation, y equals to 3x plus 2. Y equals to 3x plus 2. So when you have the equation y equals to 3x plus 2, and you are told to compute its gradient, what do you do in that scenario? Y equals to 3x plus 2 is your equation. Yes, y equals to 3x plus 2. When you have y equals to 3x plus 2 and you are told to get its gradient, how do you approach this? Allow students, we flash back to Form 1 work. You are given some equations of this kind, then you are normally told to plot them on a graph. Do you remember how you used to do that? Yes, the same approach is the one you are going to apply here. So someone is telling me that in order to work it out, you are being told you draw a small table, at least pick 2 x values, and for each x value, get its corresponding y value. And now you plot them. Now that is the point. Those are the points through which your line will be passing through. So the same concept, you are going to apply it here. So you can have just a small table. You can have a small table like this. This is x, this is y, okay? Let's pick any 2 x values. For example, even you can just pick 2 and 4. 2 and 4. So x2 and x4, like that. Then for each corresponding x value, compute its y value. For each corresponding x value, compute its y value. So when x is 2, what is the value of y, dear students? When x is 2, what is the value of y, dear students? You come to your equation, that is y equals to 3x plus 2. Then, wherever there is x in that equation, we input the value of x, which is 2, okay? So for this case, it will be 3 into 2 plus 2. What are you getting? 3 into 2 is 6, plus 2 gives you 8, meaning when x is 2, y is 8. Y is 8. What about when x is 4, dear students? You realize that when x is 4, y will be equals to 3 into 4 plus 2. 3 into 4 plus 2. So 3 into 4 becomes 12. Plus 2, that becomes 14. Now, by having that drawing, now you have, by filling up this small table, now you will be able to have your 2 points, dear students. Remember that a point is normally represented in the form of xy coordinate. So the first point is xy, that is 2. When x is 2, its y becomes 8. That's your first point, that is 2, 8. The next point you'll be having is when x is 4, y will be 14. So you have the point 4, 14. Now you have those 2 points. I think now it is very easy because it is just the same concept as the one we used to apply before. Gradient is simply given by change in y over change in x. Now, dear students, the gradient is change in y. The change in y, I said, it is the change in the y values, okay? For my case, I can say it is 14 minus 8. So, 14 minus 8 all over the change in the x coordinates. The change in the x coordinates is now 4 minus 2. It is now 4 minus 2, dear students. Now, 14 minus 8, what are you getting? Yes, you are getting 6. So this is like saying 6 over 2. Now, 6 divided by 2, you'll be getting 3. You'll be getting 3. That will be the gradient of that line. That will be the gradient of that line. Now, what is the most common challenge that a student is likely to face in this question? Mostly in this subtopic of finding the gradient. Now, whenever we are marking the students' papers, I've come to note that most students have a challenge of interchanging the x and the y values. And please, dear students, I want to draw into your attention that when you have these points, allow maybe I call this coordinate point A, this code point B. There is something I want to emphasize on here, and I need you please to take key note on that. If you look at my working, on the y values, I took the y value of B minus the y value of A. Now, if I began by taking the y value of B minus the y value of A, I should also take the x value of B minus the x value of A. Please don't come and say 14 minus 8 over 2 minus 4. That will be wrong. I think that is a common challenge to most students. What I'll only encourage you, dear students, is keep doing a lot of practice on these questions. Keep doing a lot of practice. The more you practice on these concepts, the more you will enjoy your mathematics exam. So, take away assignment. Take away assignment, you can say. Take away assignment, you can put down this. That a line with a gradient of -3. Maybe I just write it here on board. So please make sure you attempt this assignment so that you check your level of understanding on the subtopic. So you say that a line with gradient of -3, a line with gradient, of -3 passes through the points, passes through the points 3K. The first point is 3K and K8 and K8. Find the value of K. Find the value of K for marks. Please go attempt that. Then the last question I want to give out to. Then the last question, you say, find the gradient of the line passing through. Find the gradient of the line. Find the gradient. Find the gradient of the line. Find the gradient of the line passing passing through Roman 1, 1 negative 1, 1 negative 1, and negative 3 negative 9. Negative 9. The last bit of it, Roman 2. Another point, find the gradient of this line. Negative 3, 4. Negative 3, 4. And negative 5. Negative 5, 7. So please, dear students, make sure you attempt those questions at your own pleasure. Thank you for this session, dear students. I appreciate you all for attending my lesson. I remain yours, Brian Odongo. Thank you very much. The session is over.